Alright, today we are going to do chapter 1, real numbers. What are real numbers? Everything that you have learned from your kindergarten till class 9 is a real number. Now in class 9 you might remember learning the types of number. You have learned the types of number. That includes almost 80% of a real number. Few things are new here which I shall explain with the help of a diagram so that it becomes easy for you to understand and also to remember. Here the first thing you have is real number. Real numbers can be divided into two parts, irrational number and rational number. Then again, rational numbers can be divided into two parts, fractions and integers. Nothing more with fraction, but again integers can be divided into two parts, positive and negative. Now 0 is also there. Which does not come under any category. If 0 is neither positive nor negative. Now one thing is positive integers and negative integers. Now, if we take positive and 0 together, then we get whole numbers. You have studied this thing in class 9. Whole numbers. And positive ones have another name as natural number. Natural numbers which we use for counting. Now, you can take a screenshot of this, print it and paste it on your wall. Let me explain each one once again quickly. Whole numbers denoted by W, and it includes 0, 1, 2, 3, ... till infinity, which we can write as n. Then natural number, it is denoted by capital N, and it has 1, 2, 3, 4, ... till small letter n, till infinity, so till n. Then negative numbers is denoted by n again, but a minus sign. It can be written as -1, -2, -3, ... Then we have 0, you know already what is 0. Then we have integers. We can either write z or I to represent integers. Can be written as minus infinity, -2, ... -2, -1, 0, 1, 2, 3, ... till infinity. Then fractions, you know what are fractions. Part of a whole is called fraction. Fraction can be like 1 by 2, 7 by 11, or anything in this form. After fraction, we have rational numbers. Now, the definition for fraction number is any number which can be in the form of p by q, where p and q are co-prime integers. Co-prime integers and q not equal to 0. This is an important point which we will use while solving rational and irrational number. Now rational numbers equals to p by q, so irrational number should not be equal to p by q. Now real number includes everything in it. Till this much you have studied in class 8. Then till this much you have studied in class 9. A little part of rational number you have studied in class 9. And in class 10 most of all you are going to deal with irrational number and rational numbers. You already know what are these things you have learned from before. But when it comes to rational number and irrational number, we have to give justification, or say we have to prove them. Now how to prove a particular number as rational or irrational we shall learn next. Now one of the most common question in class 10 is prove that root over something is an irrational number. Now it can be anything. I'll do with 5. The answer remains same, be it any number. You have to just change the number. Now how to solve this? this is an irrational number. First, we will assume this to be a rational number. Then we will prove ourselves as wrong. And ultimately, if it is not an rational number, then it becomes an irrational number. Now, first, let it be a rational number. Let root 5 be a rational number. Now, if this is a rational number, how can we write this? We can write root 5 equals to p by q. This is the definition of rational number. Any rational number can be written in the form of p by q. Then write in the complete definition where p and q are co-prime integers and q not equal to 0. Now, what is the meaning of co-prime? Co-prime means there is nothing common in between them. We cannot cancel it. This is the simplest form. Now, we will square both sides. On squaring both sides, since we need to remove this root over, we have to square it. Now, root 5 square equals to p by q square. If we square this, it becomes 5. Root over and square is cancelled, equals to this becomes p square and q square. Now, if we cross multiply, it becomes 5q square equals to p. This is divide here. If you send it to the other side, it becomes multiply. Now, 5q square equals to p. Now, what does this mean? That is 5 is a factor of p square. How can we say this? See, what does this mean? It means 5 multiplied with q square gives you p square. That means 5 multiplied with whatever gives you p square. Now, this can be anything. Let it be whatever is equals to p square. That means 5 multiplied with something. In 5 multiplied with something gives you p square. So, 5 is a factor of p square. If 5 is a factor of p square, then 5 is a factor of p also. Now, if 5 is a factor of p, then can we multiply 5 with something and get p? 5 multiplied with, say, x, and we get p. Can I write it as 5x equals to p? Now, put this value. Putting p equals to 5x. Now, if we put p equals to 5x, what we will get? We will get 5q square equals to, instead of p, we are going to write 5x. So, 5x. This was p square. So, we have to write p square. Now, solve it. 5q square equals to 5 square will give you 25 and x square will keep it x square. Now, if we write only q square here, we will get 25 x square divided by 5 on the other side. We can cancel this. Both the numbers are divisible by 5. 5 ones are 5. 5 fives are 25. It gives you q square equals to 5x square. So, same thing we got like previous one. We can write 5 is a factor of q square. That is 5 is a factor of q square. Now, 5 is a factor of q also. If a number is a factor of square of something, then it is a factor of that number also. Now, 5 is a factor of q also, 5 is a factor of p also. Can we write 5 is a factor of both p and q? Now, if 5 is a factor of both p and q, that means p and q are not co-prime. The meaning of co-prime means nothing is common in between them. They have no common factor. Here we have 5 as the common factor, so they cannot be co-prime, which means our assumption is wrong. Which means p and q are not co-prime. Which means our assumption is wrong. Thus, our assumption is wrong and root 5 is not equal to p by q. If root 5 is not equal to p by q, that means root 5 is, therefore, root 5 is irrational. Hence proved. Now another common question in class 10 is prove that root any number, say like 2 plus 5 is irrational. Now how to solve this? How to prove this? Again we are going to take the same thing. We will assume this to be as rational number and prove ourselves as wrong. Then ultimately it becomes an irrational number. So let root 2 plus 5 be a rational number. Now if this is a rational number, we can write down the definition of rational number. Root 2 plus 5 equals to P by Q, where P and Q are co-prime integers and Q is not equal to 0. This is the definition of rational number. Now keep this root 2 here equals to P by Q. This 5 was plus here. If we send it to the other side, it comes as minus 5. Now P, Q and minus 5 all are integers. P and Q are integers, which we have said here, and minus 5 is an integer. We know all the positive number and all the negative numbers are integers. Everything is integer here. So now P, Q, minus 5 are integers. Therefore this is your RHS. RHS is rational. Now if RHS is rational number, that means it equals. Now if RHS is rational number, we have written equals to this. If this is rational, that means this is also rational. If RHS is rational, that means LHS. This implies LHS root 2 is also rational number. But this contradicts the fact that which contradicts the fact. What is the fact? The fact is root 2 is an irrational number. We have already proved it earlier. Root 2, root 3, root 5, root 7 are all irrational number. We have already proved. But now we are telling that it is rational number, which means our assumption is wrong, which contradicts the fact that root 2 is irrational. Thus, our assumption is wrong. Our assumption that root 2 plus 5 is a rational number. Our assumption that root 2 plus 5 to be a rational number is wrong, and hence it becomes root 2 plus 5 is irrational number. Now we will use the same method for solving irrational numbers from any number, be it any number, say like root 2, root 5, root 3, plus 7, minus 7, 100, 10, 50, whatever it may be. We are going to follow the same method. We will take all the numbers to the other side, keep the root here, and after sending the numbers to the other side, P and Q are already integers, the number is also integer. That means everything is integer, and if it is integer, it becomes a rational number. If this part becomes a rational number, that means the other part is also rational number, which is not true. We know that the root of any prime number cannot be a rational number. It becomes an irrational number. Thus our assumption becomes wrong, and if our assumption becomes wrong, that means calling it as rational number is wrong. It is a irrational number. Hence